We're going to be covering hydraulics in 2 hours. Everything you need to know about hydraulics. So what we're going to do is we're going to watch a film. The film is going to go through a hydraulic system, and it's got some animation in it, and they kind of go through how it works. So it goes through the fundamentals. Then we'll talk about it just a little bit, and then we're going to watch a film just on hydrostats. Most of the equipment that we're working with today on a golf course is going to be a hydrostat. It does not tolerate any kind of contaminations. And so we're going to look at it. What makes a hydrostat work, and why is it so important and so critical that we do not get contaminants in it? And so we're going to watch a film on that. We have a few hydrostats here, and so that's what this is a hydrostat. We can look at them. Any questions you have, we can answer. But for the most part, the fastest way to cover that broad of a spectrum in a short time is to watch this film. It's actually a very good film. So we're going to watch that film first. We're going to be looking at this sheet right here. I'm going to quit moving around. The thing about the video that we watched, what it does is gives you a pretty good overall view of what a hydraulic system is, what makes it up, the components that make it up, and just kind of how it kind of fits together, and the features that make it fit together. Hydraulics, the invention of hydraulics has made our lives as landscapes or lawn and garden business or golf business sweet. I mean, it is so nice. Without hydraulics, we'd be back to chain drives and belt drives and mechanical gearboxes with drive shafts, and it's just cumbersome. And just, if you've been there and played with it, if you've driven old equipment that doesn't have hydraulics on it, you know, you're lifting reels up by hand, or you're turning a hand crank trying to get them off the ground. The invention of hydraulics is just phenomenal. And the nice thing about hydraulics is, just like the video shows, it doesn't matter if this huge monstrous crawler, or if it's a little greens mower, or if it's a lawn and garden tractor. It has the exact same components, and it has the exact same theory all the way through. The hydrostat used in a lawn and garden tractor is the exact same function and looks exactly the same as it would in one of those big crawlers that's, you know, pushing dirt. The only difference is it's a lot bigger. So if you understand it at the lowest level, you'll understand it at the biggest level. So it's not like you're reinventing the wheel. So that's the nice thing. And on the first page, I talk about the principles of hydraulics. Why does it work? What makes it work for us? And there's 4 basic principles that hydraulics are made on. First one, they have no shape of their own. So it doesn't matter how you ship it or what container you put it in. It doesn't matter what the reservoir looks like. It could be long and narrow, or tall and short and fat. It could be bent around things. Tanks can go anywhere. Hoses can go anywhere. I can take a block of metal and I can drill orifices of varying sizes, and the hydraulic will simply fill the cavity, and it will apply pressure the same amount no matter where it goes. And that's what makes it so flexible. And so flexibility is a tremendously important feature that we utilize hydraulic oil. They are practically incompressible. It compresses so little that for all practical purposes you can't even hardly measure it. And so when I put an ounce of oil into a hydraulic cylinder, it's going to move the distance that ounce has to take up for space. And so it's not like an air cylinder. If you have air cylinders and work with it, as the weight increases in an air cylinder, it'll compress the air and the load settles. It becomes spongy. As the load decreases, it starts to bounce a lot. Hydraulic oil is very precise. I can take and bump a hydraulic valve just a little bit, and I can move it 1/4 of an inch, 1/8 of an inch, 1/16 of an inch, or a foot, like very precisely. I mean, I can move it exactly where I want it, because it's like moving steel in there. It's just solid, and it doesn't give, and that's good. It transmits power in all directions. So when I put it into a cylinder, the exact same amount of pressure is applied both on every single surface in the entire system. Wherever the hydraulic oil is at, it's applying the same amount. If you put 100 pounds of pressure into the system, 100 pounds is put on the hoses, it's put on the fittings, it's put on the cylinder walls, the bottom of the cylinder, and on the piston. And the only thing that's going to move is whatever is the weakest link. If the weakest link is the piston and the cylinder, it's going to move. If the weakest link is the hose, it's going to move. If it's the pump, it's going to move. And so it's going to find that object that 100 pounds can move, and it will move it. If it can't move it and there's no place to go, and I try to put more oil in, I put another ounce in, something has to give. And that's the thing about all hydraulic systems. Pumps create flow, and they're always going to keep putting flow into the system. If you don't give it a path to go, it will break something. And so if you get to messing with a hydraulic system and start playing around with those valves, you can cause catastrophic damage to it. And you want to be careful with it. So treat it like it is. It needs to be clean, and you don't want to mess with the valves. Unless you've read the manual and understand hydraulics, don't mess with relief valves because it'll blow it up. The very